Please, please mute yourself. Do not ask anything. Everything is going on automatically. If you have joined the class, definitely attendance will be counted here only. So don't worry. Do not write anything here. So I was discussing about this the history of this BHDL. Actually, there was need to generate one common language, that is IC language. It was the need by Department of Defense in US. That time many companies were doing work on this, and they generated language for this IC. However, there was it was not easy for Department of Defense there to accept that language. Basically, different vendors were using different techniques, and each technique has merits and demerits. However, Department of Defense, that is in US, that was accepting positive side of each company, and to correlate all of them, it was not easy for them. That's why uh, mm, this contract, defense of US has given the contract to a specific companies like that time Intel, Texas, and one other company. These three companies were given one contract that combinedly you should have one common language for IC, so that Department of Defense can use it for its own purpose. So that time this contract was accepted by them, and they designed one language, that is BHDL. It has the common link with all these companies. They generated the that is designed this language in 1983, and 19 and I think 1985. It was 1985. They have given this language, design of this language to Department of Defense. It was launched. The first version of this language was launched in 1988. Then it got a wider publicity, and so today we are discussing the same language. Actually, BSDL is related to high speed integrated circuit hardware descriptive language. This is related to designing of different digital circuits that may be combination or sequential. Please do not draw these bubbles here. Whoever is doing it's not a good way. Don't do so. So see VSDL, else I will remove you. VHDL is basically a language that is used to design. Why he is doing so? See here, it is a language. Remove these. Who is doing this activity? So see here, what is BHDL? BHDL has basically, it is a technique. It is using two part. That is, one is interface path and other is body part. Here, in interface part, basically one block. What type of block is this? Suppose I want to design AND gate, then AND gate is accepting what type of input? What type of input means? Suppose this is one AND gate, this is one AND gate, it is accepting two input here. It is providing you one output. So this part is designed by this interface part. Interface part. This part is designed by this interface part. I'm just sharing it again. So here this VHDL entity part, actually this is used to design the black box. What type of input this device is accepting and what type of output it is giving. How many inputs are accepted and how many outputs are given. This is designed by this interface part. Basically, every BHDL language will have two part. One part is interface part and other part is architecture part. So interface part, I'm discussing this interface part. Interface part would include only a black box design. What type of input is it is accepting, what type of output it is giving you. Then is the architecture part. Actually, architecture part says how this input is reaching to the output, in what way this input is reaching to the output. Basically, this is designed by in the architecture part. This is discussed. This architecture part may be working in sequential way, maybe working concurrently, maybe working in sequential way, maybe working concurrently. Concurrently basically means at a time the program will be simulated. Sequentially means line by line program will be simulated. Basically, this says that this VHDL language will work for both combinational as well as sequential circuits. And there are different libraries that are used. I will discuss this also. Like see, this is one OR gate. See how it is written. It is entity OR gate. Then is port is basically it will say it contains input and output description. What type of input is there, how many inputs are there, and how many outputs are there. So that is written inside the port a comma b in bit. Basically see a and b, these are input here. That's why it is written a b in bit. Bit is basically what type of input is this. It is integer type or it is bit type. So you have to write bit. It is bit. That's why it is written bit type. Then c is out is of what type. It is of bit type. And then and or gate. Whenever you are breaking any statement, you should use semicolon. Colon is used to denote what type of input it is. See, there is semicolon. Semicolon is used to differentiate between two statements. Like see, A, B are of same type. That's why it is colon in bit. It may be written as A colon in bit, B colon in bit, and then C is out bit. Then is AND OR gate. So I'm just doing the same thing um, on software. See, it is the software here. This is a model sim. I'm doing the work on model sim. Here you can see just I'm starting from the initial position after installing the program, after installing this software on your system. Just use this way. You will go on project and then you will create new. It is asking what type of project you want. Let it be day 1. See, whatever you are writing here, there must not be gap between two sentence, between two words. You have to take care. There must not be any gap between two word. Either you will use underscore or hyphen, but there must not be any space there. The word should not start with any numeric value. With after one word you can use numeric value, but directly you cannot use numeric value here. So see here, day 1, I'm okay. It is giving you location also where file is to be saved there. Then you will click on create new file. Then you will click on create new file. You will click on create new file. It will ask you the file name. Let it be AND gate. And gate. It is okay. Then close it. And then see here it is AND gate. I am writing
हाँ रे
entity
चल रहा है।
and
ए देखो राम क्या गलत था।
so it is entity and gate and underscore one gate. Port, and then let it is accepting. See, it was there. It is accepting two input. I'm discussing about one and it accepting two input and providing you one output. So here you will write port and a comma b colon in bit. Then you will use semicolon there, and then let C is the output, C colon out bit. Then you will use bracket here. It was initialized by small bracket, will be closed by a small bracket, and then you will end the statement. To end the statement, you will use colon here. Then write and entity, entity, and entity. See, the alphabets, the sentence that are written in red font, actually these are the syntax here. Alphabets that are written in red font, these are syntax. Written in blue color, blue, these are variable here. It will change as per the user. Bit it is, and actually it is a type that is given in the library of the software. So it is understood by the system that what type of things are there. So I've discussed this entity part. Entity part will discuss the black box. The black box, that is whatever you are programming, what type of content it is accepting, that is written inside the entity. Then is architecture part. See architecture part, how it is written. Here it is written and or port map or it was started with and entity or is. Entity or is, actually you cannot write directly or here. Basically, or is understand, actually it is inside the library. That's why write something else like and underscore one and one, it will be accepted. Then it will be written architecture. Architecture, see, architecture is written in three way. Either it will be data flow, it will be behavioral, or it will be sequential. So it will be structural. Actually there are three the way you will write architecture, it has three technique. Either you will use behavior, you will use data flow, or you will use structural. There is difference between these three. Actually, see, data flow is used wherever you are not using if else condition. If you are not using if else condition, it's better to use data flow. If you are using if else conditional statements, if you are using to design a mux, if selection input is this, then output should be this. If selection input is x, output will be y. If else condition, while condition, conditional statements if you are using, then you will use behavioral style. If conditional statements are not used, you can use data flow. Data flow is used for normal circuits. Similarly, a structural circuit, a structural style, where you will use a structural style wherever there is a repetition of some blocks, like and is repeated multiple of times, and is repeated, there you will use a structure. So this is the basic difference between different styles. So I'm just writing data flow. After architecture, it is written begin. Architecture data flow of and underscore one is begin, and then write, you have to write how output is obtained here. So logically it will be written as a less than equal to a and the and b, and then enter. See, to assign any value to any alphabet, to any assigned output, you will use this less than equal to. This less than equal to, it is the uh, assigning way, that less than equal to. In this way, like you cannot directly write c equal to assign value, you will use this symbol less than equal to. It is technique that is used here, less than equal to. Actually here this is defined that some nanosecond delay will be taken to obtain the value of c. There are some way of assigning way, like less colon equal to, this is also the assigning way. Normally this will be used. It is 1 nanosecond, 2 nanosecond delay. After certain delay, she will get the output. Then I'm writing and architecture, a archi tectura, and architecture, and it, and architecture. See, you can see different colors here. This these the font that are in red, they are basically syntax. Compiler will check this syntax only. This syntax will be checked by the compiler. However, the logical statement will not be checked by this compiler. Logical statements will not be checked by the compiler. You have to take care what type of circuit you are designing. You are designing AND gate, so logically output will be obtained as A and B. See here, you are getting the architecture via coding. This is a technique. This coding is a technique where you are getting the circuit via coding. Coding helps say you are getting the circuit via coding. So here, after writing this program, I'm just saving it here, and then see is there any error or not. For that, I'm using compiler here. Compiler is available here, or here it is compiler. So compile selected. See, there is no error. So compiler is saying that compile of end underscore g dot vhd was successful. Now suppose I'm removing this column. I have removed the column and then again saving it and then running the same compiler. See, it is saying that compiler has one error. What is that error? Try to understand this error. Basically, to understand the error, it is also a way to learn the program. Sometimes it will say error exactly, sometimes it will give you just a hint where will be error. See, it is saying near end architecture expecting this column. Yes, the same error is there after this statement, that is after assigning as a statement, there must be one column there. That's why there was error. Now again save it, again run the program, run the compiler. See, it is successful now. Just run the, after compilation you have to simulate the program. Simulate means you need to obtain the output, how output is visible, how output is visible. So for that, what you have to do, you have to either reach here, simulate, start simulation, or there is one option also here. I'm just clicking on this simulate, and there are multiple options available there. Do not focus on all, just focus on the first part, that is work. Click on this plus part. On clicking plus part, try to match the options that are available here with the entity name. Entity name is end underscore one. See, it is end underscore one that is available upside. Okay. Now, after running this, after simulating this, you will have this type of window in front of you. The instant window, that is just the leftmost. There you will click and you will have left click, that is left hand. When you will click, you will have these options. When you will click on this, you will have these options. When you will click the right hand of your mouse, you will have right button of your mouse, you will have these options. Now what you have to do, you have to select add wave, add to, sorry, add to, then on wave, add to, add to, then on wave, then all regions in, all items in the region. Just click on this. You will have the waveform that is simulating a window in front of you. At the same time, just click on the instant, and there where you are using add wave, data flow, all items in the region. See what is there. This time it is not working. Don't worry, it will work. Just focus on this waveform. See how it is showing the output. A and B, these are the inputs and C is the output. You should know what are inputs and what are outputs. System is not knowing. Actually, it will behave as you will act. It will behave as you will act. It is not going to give you the correct output if you are not if you are giving incorrect input. So you should know, among all these three that are three variables that are available here, among these, whom you have assigned input and whom you have assigned output. The variables that has been assigned as input, to them, clicking on the right key of your mouse, just click on force here, F force here, and then see value of A is 0. I am putting here 1. Value of B is 0, putting here 0. Don't worry. Putting 0 here, and then see what is the output. To get the output, you will click just after clock. Just after clock, there is one arrow here. Click on this 100 ps. 100 ps means 100 picosecond. That is the time cycle, that is the clock cycle has 100 picosecond time period. So on clicking on run, you will have this output. See, 1.0 is what? 1.0 is 0. Now suppose I'm giving here input as 1 here, then what is the output here? See, 1 1.1 is giving you 1. So in this way it is working. Just I'm changing the input as a clock. See what is the output. See, when a is 0, actually wherever there is this cursor is, it the numbers that are shown here, it is showing as per the position of the cursor. As per the position of cursor, it is showing the output. See, when when it is 0, that is a is 0, b is 1, output is 0. When initially when a is 1, when a is 1, b is also 1, output is 1. In this way you can see truth table is verified. When both are 1, output is 1. When any of them is 0, output is 0. When both are 0, output is also 0. Like if suppose I'm making b 0. See, it is always output is always 0. Suppose I'm making I'm inputting it as a clock here, 100 ps as a clock. I'm feeding this as an input. See what is the output. It is varying, then it is getting 0. It is getting 0 already. So I think this AND gate is verified. Any one of you is running this program? Yes, anyone?
Please repeat this. Zero
Yes,
one.
yes, Rohit.
सर ये वाला फिर से थोड़ा रिपीट कर दीजिए.
फिर से रिपीट करें. Okay,
Yes.
okay, fine. I'm ending this simulation. uh, See, I'm writing the same program like it was and or. Suppose I'm preparing one program for OR gate. So OR underscore 1 I have written here. It is accepting two input, that is A and B, and is giving you output C. In entity part, you will give the black box view. Black box view means what type of, how many inputs and how many outputs it is accepting, that is written in black box. Same. And then is the architecture. After entity part there will be architecture part. In the entity you have to focus that inside port input and output details are written. Here A and B are in bit, so it is written in bit. The font, the word that is in red font, these are syntax. These are understood by the compiler. There must not be error in these. The font that are in red, the word that are in red, they are understood by the compiler. So you have to take care on this. Here it is in bit, C is the out bit, and that is then it is an entity. Whenever you are breaking the statement, there must be semicolon there. After entity part, architecture part is written. Architecture, the way it is written, you have to learn this. Architecture data flow, architecture data flow of n underscore 1 is, then you have to write this statement. Architecture data flow is basically architecture style, what type of style you are using to design the architecture. That's why it is written architecture data flow of and underscore 1 is. Then after this statement you will write begin, begin, begin. It is also syntax. After begin you will use logical statement here, how output is obtained using input. For that logical function you should know to get the output. So here it is written c is less than equal to and b, a and b, c is less than equal to a and b. Then it is end architecture. So after writing these statements you will click on save. After saving it you will compile, you will compile. See, within this project I'm working, that is initially it was and g. Actually within and g I'm writing or get. So don't worry, uh, I'm compiling the program. It is saying successful compilation is successful. After successful compilation I will simulate. Simulation is done to see how output is visible, how output is visible. So start simulation. It's request to you all to write this process if software is not in front of you. During revision it will help you. After compilation I have clicked on simulate. After simulation this type of window will appear in front of you. Then click on work. On clicking the first option, that is work, you have to find, actually the software is being used, initially it was used, so multiple programs are visible here. You have to match your own program. What is the name of your program? It is entity or underscore one. Actually file name should be or underscore one. So you have to you have to find the same name here, or underscore one. See, or underscore one is here. I have clicked it on that, and then is okay. There is some error in the design. Error is that architecture data flow of which gate, it should be or underscore one, or. And see, there is syntax, there is a uppercase and lowercase funda also here. There is difference between uppercase and lowercase here. There is no difference between uppercase and lowercase here. There is no difference between uppercase and lowercase here. It is case insensitive. As in case of MATLAB, uppercase and lowercase has different values. Here both have the same values. There is no difference between capital A and a small a here. So, and architecture, and then I'm again compiling. It is saying it is okay. Again it is saying yes, and g, actually it is and g here. However entity name is or underscore one. Logically it should be or also. Again save, again compile selected, and then simulate. Start simulation. On simulation you will go towards work. There you will find or underscore one. You have to find or underscore one. Yes, it is or underscore one. On clicking here, make it okay. And after okay, you have to work on instant window. at instant window, the first option. By default, it is selected. You have to click after right click. After right click, you have to focus on add to wave. Actually, to wave, it will be used to get the simulation result, all items in the region. Even this will help you to get the structure also. Now see the waveform. Give this output. I have selected both and then right click. On right click, click on force. Give the value 1. Let other be 0. That is B is 0. And then run the program. Or for running after clock pulse, you will click on this. Run. See, when A is 1, B is 0, or of A and 0 is 1. I'm just making it as a clock. You have to write PS here. It is written PS picosecond. You have to write PS here. Keep the clock and see the result. See the result. Initially, it is 1 1, then is 1 0, then again is 1 0, 1 1. Output is 1. Now, suppose I'm using it as a clock. Input is as a clock, and I'm written here. It is 150 picosecond. 150 picosecond, and then I'm clicking. See the output. Initially, when both are 0, see, when both A and B are 0, output C is 0. When initially A is 0, B is 1, output is 1. When A is 1, B is 0, output is 1. When both are 1, output is 1. When any of them is 1, output is 1. When both are 0, output is 0. So in this way, OR gate is verified here. This is simulation, and then is coding, and then is simulation. You have code, and then you have simulated. Yes, is it clear? Is it clear to you all? Anyone?
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
Anyone of you running this program? You are
Yes,
running.
sir.
No,
So today, after this class, you have to run the program on your system. Before that, try to install your software properly, and then try to try to run these programs. Okay.
Okay,
So
sir.
I'm just ending
okay,
this
sir.
simulation. I'm just ending this simulation. And suppose I want to have one program like XOR gate. So I'm adding this to the same project. I'm writing XOR gate. Clicking on this, we'll have this. Then write entity XOR. You cannot directly write XOR. You cannot directly write XOR here. See, you cannot directly write XOR. If you're writing XOR, actually it is getting a logical value here. You have to XOR entity or something. So there will be error here. For that, what you have to do, for that you have to write XOR underscore 1 each, and then you have to write port what type of input is it is accepting. Suppose it has three input, a comma b comma c. It is in bit. You have to write in bit. I'm just I want to have one XOR gate that has three input and is providing you one output. So in bit, then is colon, and then let O is the output, O colon out bit, out a space bit, and then end the statement. Then write end entity. Okay. After that, write architecture. After that, write architecture XOR underscore 1 each, then write begin, then write you have to write logically how output O is obtained. So O less than equal to, this is assigning a statement less than equal to A XOR B. You have to use a small bracket here. Output of this XOR will be again XOR with C, and then end the statement, and then end architecture, and then end architecture. And then end architecture, save it, and then compile it. See, it is saying there is error. Now try to find what type of error is this. It is saying off line number 4. Line number 4, it is saying data flow. It is should be data flow of now again
सर
7
मैं
it.
हाँ देखता
Okay, okay,
सर
okay,
क्लास में
students.
आ गई सर।
Okay, students. I'm just closing the session. Recording will be shared with you. Revise on this.
Okay, sir.
Oh.
ओके सर।